Vanakkam, now we are going to solve problem 3.1D from Digital Design by Moris Mano's 5th edition. Actually, the question is to simplify the following Boolean functions using 3-variable map. So the D part is f of x comma y comma z, that is equal to sigma 1 comma 2 comma 3 comma 7. This is summation of the minterms. So for this we are going to draw a 3-variable K map. So it consists of 8 number of cells and the variables are x, y and z, and row wise we have the variables placed as x dash and x, and column wise it is y dash z dash, then y dash z, then y z, then y z dash, and the corresponding cells are marked with the minterms x dash y dash z dash. This cell consists of x dash y dash z, then this cell corresponds to x dash y z, and this cell x dash y z dash. And for this cell it is x y dash z dash. For this cell it is x y dash z. Then for this cell it is x y z. For this it is x y z dash. And this minterms are now actually replaced by their equivalent decimal values. So it is 0, 1, 3, 2, then 4, 5, 7 and 6. Now we are going to place ones for the corresponding minterms into the corresponding cells. Okay, so for this one we place a 1. Then the second minterm, isn't it? For the second minterm we are going to place a 1 into this cell. Then for this third we are going to place a 1 into this corresponding cell. Then for this 7 we place a 1 into that cell. Okay, so the next step is to combine the maximum possible number of adjacent ones in powers of 2. So here we don't have 8 number of ones in all the cells, and we don't have 4 number of ones in adjacent cells. So we are going to form 2 number of ones as a loop. So these two can be combined and we name it as loop 1. And these two can be combined and we name it as loop 2. And then this third cell and the seventh cell can be combined and it can be named as loop 3. Now we have to find out the corresponding expression for this loop 1, 2 and 3. So this loop 1 actually combines this first cell and the third cell, isn't it? So this first cell corresponds to x dash row wise. Similarly, this third cell corresponds to x dash. So we can mark x dash here. Then when you go for column wise, this first cell corresponds to y dash z. So it can be marked here. And this third cell corresponds to YZ column wise, so it can be marked. Okay, so we have this expression framed x dash y dash z y z, and in this y dash and this y or complement of each other, they can be removed. Similarly, the z gets repeated, so it is redundant, so one term can be removed. So now we have finally this x dash and z. Okay, so this is the simplified expression for this loop 1. Now we move on to loop 2. So this loop 2 covers this third cell and the second cell. So these two corresponds to row wise x dash literal. So we mark it here. And then next, if you look at column wise, so this third cell is covered by YZ, so we can mark this YZ here, and this second cell corresponds to YZ dash, so that can be marked here. So now we get x dash y z dash, isn't it? So here we have the complement and the original values for this z and z dash, so they can be cancelled. And the y is repeating, so it is redundant, so it can be removed. So now we got the simplified expression as x dash y for loop 2. Now we move on to the third loop. So this third loop combines this third cell and the seventh cell. This seventh cell covers row wise the x variable, so it can be placed here. And this third cell covers x dash variable row wise, so it can be placed here as x dash. Then column wise, if you check, that third and seventh, they cover only y z. Okay, so it can be marked here. So we got this expression as x dash y z. In this x and x dash are complement of each other, so they can be removed. Remaining expression is y z. Okay, so this is for loop 3. Now we can write the simplified function as this x dash z and then this x dash y plus this y z. So all the three expressions are combined using this plus operator. Okay, so we got the simplified one. So this is the answer. Thank you. Hope you have understood.